Series rating of a branch panel can be done if the feeder breaker provides ample short-circuit protection. There are a few requirements for series rating. Firstly, the feeder breaker ampacity must be equal to or greater than the sum of the ampacity of all branch circuits in the branch panel. Secondly, the feeder breaker must have an interrupting capacity equal to or greater than the maximum available short-circuit current at the branch panel. Thirdly, the branch circuits must be rated for the maximum current that can flow through them under normal operating conditions. You cannot bypass the fully rating requirement by upsizing the remote terminal unit, or RTU, breakers at a higher ampere interrupting capacity, or AIC. The AIC rating of the RTU breakers must match the interrupting capacity of the feeder breaker. Series rating involves coordinating the interrupting ratings of overcurrent protective devices to achieve adequate protection against short-circuit currents in an electrical distribution system. It's a cost-effective alternative to fully rating all components, where each device must independently interrupt the maximum available fault current. The National Electrical Code, or NEC, permits series rating under specific conditions, focusing on safety and proper coordination. To determine if series rating is appropriate, calculate the available fault current at the branch panel. This calculation requires knowledge of the utility's available fault current at the service entrance, transformer impedance if applicable, and conductor impedances between the service entrance and the branch panel. Software tools and online calculators can assist with these calculations. Once the available fault current at the branch panel is known, verify that the feeder breaker's interrupting rating is equal to or greater than this value. The interrupting rating of a breaker is the maximum fault current it can safely interrupt without failing. The feeder breaker must also have an ampacity equal to or greater than the sum of the branch circuit ampacities. This ensures that the feeder breaker can handle the total load of all branch circuits connected to the panel. Each branch circuit breaker must be rated for the maximum current that can flow through it under normal operating conditions. This ensures that the breakers can handle the load of the equipment they supply without tripping unnecessarily. However, simply upsizing the RTU breakers to a higher AIC does not satisfy the code requirements for fully rating the system. The AIC rating of the RTU breakers must still match the interrupting capacity of the feeder breaker. In a series-rated system, the downstream breakers rely on the upstream breaker to limit the fault current to a level they can safely interrupt. If the downstream breakers have a lower AIC rating than the available fault current, they could fail during a short circuit, even if they are upsized in amperage. The NEC provides guidance on series rating in Article 240.86, which outlines the conditions under which series ratings are permitted. These conditions include that the series combination is tested and marked by the manufacturer, and that the downstream breakers are suitable for use on the system with the available fault current. It's essential to consult the manufacturer's documentation and the NEC to ensure that the series rating is properly applied. In summary, you can series rate the branch panel, but you cannot bypass the fully rating requirement by upsizing the RTU breakers. The AIC rating of the RTU breakers must match the interrupting capacity of the feeder breaker. Series rating is a complex topic that requires careful consideration of the electrical system's characteristics and the applicable codes and standards. It's always recommended to consult with a qualified electrical engineer or inspector to ensure that the system is safe and compliant. The available fault current calculation involves several factors. Firstly, the utility's available fault current at the service entrance, which is typically provided by the utility company. Secondly, the transformer impedance, which is the opposition to the flow of alternating current in a transformer. Thirdly, the conductor impedances, which are the opposition to the flow of alternating current in the conductors. The interrupting rating of a breaker is the maximum fault current it can safely interrupt without failing. This rating is typically marked on the breaker's nameplate. The feeder breaker must also have an ampacity equal to or greater than the sum of the branch circuit ampacities. This ensures that the feeder breaker can handle the total load of all branch circuits connected to the panel. Each branch circuit breaker must be rated for the maximum current that can flow through it under normal operating conditions. This ensures that the breakers can handle the load of the equipment they supply without tripping unnecessarily. The NEC Article 240.86 provides guidance on series rating, including the conditions under which series ratings are permitted. These conditions include that the series combination is tested and marked by the manufacturer, and that the downstream breakers are suitable for use on the system with the available fault current. There are several potential issues if series rating is not properly applied. Firstly, the downstream breakers could fail during a short circuit, potentially causing a fire or other hazards. Secondly, the electrical system could be non-compliant with the NEC, which could result in fines or other penalties. Thirdly, the electrical system could be unsafe for occupants, potentially leading to injury or death. To ensure that series rating is properly applied, it is important to consult with a qualified electrical engineer or inspector. These professionals have the knowledge and experience to properly evaluate the electrical system and determine the appropriate protection measures. They can also ensure that the system complies with all applicable codes and standards. Additionally, proper documentation of the series rating is essential. This documentation should include the calculations used to determine the available fault current, the interrupting ratings of the breakers, and the manufacturer's documentation for the series combination. This documentation can be used to verify that the system is properly protected and to assist with future maintenance or upgrades. Series rating can be a cost-effective way to protect an electrical system against short-circuit currents. However, it is important to understand the requirements and potential issues before applying series rating. By consulting with a qualified electrical engineer or inspector and following the applicable codes and standards, you can ensure that the system is safe and compliant. Furthermore, consider the coordination between the feeder breaker and the branch circuit breakers. Coordination ensures that the breaker closest to the fault trips first, minimizing the impact on the rest of the system. Time current curves, or TCCs, are used to analyze the coordination between breakers. A TCC plots the time it takes for a breaker to trip against the current flowing through it. By comparing the TCC of the feeder breaker and the branch circuit breakers, you can determine if they are properly coordinated. If the TCC overlap, it means that both breakers could trip simultaneously, which is undesirable. In this case, you may need to adjust the settings of one or both breakers to achieve proper coordination. Another important consideration is the ambient temperature. The interrupting rating of a breaker can be affected by temperature. High temperatures can reduce the interrupting rating, while low temperatures can increase it. It is important to consider the ambient temperature when selecting breakers for a series-rated system. Additionally, consider the altitude. The interrupting rating of a breaker can also be affected by altitude. Higher altitudes can reduce the interrupting rating, while lower altitudes can increase it. It is important to consider the altitude when selecting breakers for a series-rated system. Ground fault protection is also an important consideration. Ground faults are a common type of electrical fault that can cause fires or electric shock. Ground fault protection devices, or GFP devices, are designed to detect and interrupt ground faults. The NEC requires ground fault protection in certain applications, such as for large motors and feeders. If ground fault protection is required, it is important to ensure that the GFP device is properly coordinated with the other overcurrent protective devices in the system. Surge protection is another important consideration. Surges are transient overvoltages that can damage electrical equipment. Surge protection devices, or SPDs, are designed to protect against surges. The NEC recommends surge protection in certain applications, such as for sensitive electronic equipment. If surge protection is required, it is important to ensure that the SPD is properly coordinated with the other overcurrent protective devices in the system. Arc flash hazard analysis is also an important consideration. Arc flash is a dangerous electrical phenomenon that can occur during a short circuit. Arc flash can cause severe burns, electric shock, and even death. An arc flash hazard analysis is a study that determines the potential arc flash hazards in an electrical system. The results of the analysis can be used to select appropriate personal protective equipment, or PPE, and to develop safe work practices. It is important to conduct an arc flash hazard analysis before working on or near energized electrical equipment. Regular maintenance and testing of overcurrent protective devices is also essential. Overcurrent protective devices should be inspected and tested regularly to ensure that they are functioning properly. This includes checking the interrupting rating of the breakers, verifying the coordination between breakers, and testing the ground fault protection devices. Regular maintenance and testing can help to prevent electrical faults and ensure that the system is safe. The NEC requires that overcurrent protective devices be tested periodically. The frequency of testing depends on the type of equipment and the application. It is important to consult the NEC and other applicable standards to determine the appropriate testing frequency. Proper labeling of electrical equipment is also important. All electrical equipment should be properly labeled with its voltage, current, and interrupting ratings. This information can help to ensure that the equipment is used safely and that it is properly protected. The NEC requires that electrical equipment be labeled in a clear and conspicuous manner. Training of personnel is also important. All personnel who work on or near electrical equipment should be properly trained in electrical safety. This includes training on the hazards of electricity, the proper use of PPE, and safe work practices. The NEC requires that personnel be trained in electrical safety. Record keeping is also important. Accurate records should be kept of all electrical work, including maintenance, testing, and repairs. These records can be used to track the performance of the electrical system and to identify potential problems. The NEC requires that certain electrical records be maintained. Electrical safety audits are also recommended. An electrical safety audit is a comprehensive review of an electrical system to identify potential safety hazards. The audit can be conducted by a qualified electrical engineer or inspector. The results of the audit can be used to develop a plan to correct any identified hazards. It is recommended to conduct electrical safety audits periodically. In addition to the NEC, there are other applicable codes and standards that may need to be considered. These include the National Fire Protection Association, or NFPA, 70E, which covers electrical safety in the workplace, and the Institute of Electrical and Electronics Engineers, or IEE, standards, which provide guidance on electrical design and operation. It is important to be familiar with all applicable codes and standards before working on or near electrical equipment. It is also important to stay up to date on the latest changes to the codes and standards. The electrical industry is constantly evolving, and new technologies and practices are being developed all the time. By staying up to date, you can ensure that you are using the safest and most effective methods for protecting electrical systems. In conclusion, series rate of a branch panel is possible under specific conditions, but it requires careful consideration of the electrical system's characteristics and the applicable codes and standards. Upsizing RTU breakers alone is not sufficient to meet the fully rating requirement. Consulting with a qualified electrical engineer or inspector is always recommended to ensure safety and compliance. The 400 amp feeder breaker must be suitable to handle the 8 RTU motor loads plus any additional demand present on the load side of the 400 amp MLO panel.